Welcome to our deep dive into the fascinating world of work and energy. In this video, we'll explore what work really means in physics, how energy powers our lives, and the intricate relationship between the two. From the basics of kinetic and potential energy to the principles that govern energy conservation, we'll break down each concept in a way that's easy to understand. Whether you're a student, a curious learner, or just someone interested in how things work, this journey will help you see the science behind everyday actions. Let's get started by understanding what work is and how it's calculated. In physics, work has a specific meaning. It's not just about doing chores or going to your job. Work is done when a force causes an object to move in the direction of the force. The amount of work done is calculated by multiplying the force applied by the distance moved in the direction of that force. For example, if you push a box across the floor, you're doing work on the box. The formula is simple. Work equals force times distance, or W equals F times D. This concept is foundational for understanding how energy is transferred and used. Energy is the ability to do work. It exists in many forms such as kinetic, potential, thermal, chemical, electrical, and nuclear energy. Each form can be transformed into another, powering everything from moving cars to lighting our homes. Energy is measured in joules just like work. The concept of energy is central to physics because it explains how and why things move, change, and interact. As we move forward, we'll look at each form of energy and see how they play a role in our daily lives. Work and energy are closely linked. When you do work on an object, you transfer energy to it. For example, lifting a book onto a shelf increases its potential energy. The work you do is stored as energy in the object. This relationship helps us understand how energy moves and changes form. Whenever work is done, energy is transferred or transformed, making these two concepts inseparable in physics. This connection is the basis for many scientific principles and real-world applications. Kinetic energy is the energy of motion. Any object that is moving has kinetic energy, whether it's a rolling ball or a speeding car. The faster an object moves, the more kinetic energy it has. The formula for kinetic energy is Ke a half times mass times velocity squared. This means that both the mass of the object and its speed play a role in determining how much kinetic energy it possesses. Understanding kinetic energy helps explain everything from sports to transportation. Potential energy is stored energy, ready to be released. There are several types, but the most common are gravitational potential energy and elastic potential energy. Gravitational potential energy depends on an object's height and mass, like a rock at the edge of a cliff. Elastic potential energy is stored in stretched or compressed objects, like a stretched rubber band. These forms of energy can be converted into kinetic energy when the object moves or changes shape. Mechanical energy is the sum of kinetic and potential energy in a system. In an ideal system with no friction, mechanical energy is conserved. This means the total amount of kinetic and potential energy remains constant, even as it transforms from one form to another. For example, a swinging pendulum continuously converts potential energy to kinetic energy and back, but the total mechanical energy stays the same. This principle helps us understand how energy moves in systems. Power measures how quickly work is done or energy is transferred. It's calculated by dividing the amount of work done by the time it takes to do it. The unit of power is the watt, named after James Watt, and 1 watt equals 1 joule per second. For example, a powerful engine does more work in less time. Understanding power helps us compare the efficiency of machines and devices in our daily lives. Principle of conservation of energy states that energy cannot be created or destroyed, only transformed from one form to another. This fundamental law applies to all physical processes. For example, when you ride a bicycle, your body's chemical energy is converted into kinetic energy. No energy is lost, it just changes form. This principle is key to understanding how energy flows in nature and technology. Work energy theorem connects the concepts of work and kinetic energy. It states that the net work done on an object is equal to the change in its kinetic energy. In other words, if you do work on an object, you change how fast it moves. This theorem helps explain why pushing harder or longer on an object makes it go faster or farther. It's a powerful tool for understanding motion and energy transfer. Energy transformations happen all around us, every day. When you eat food, your body converts chemical energy into kinetic energy for movement and thermal energy to keep warm. In a car, chemical energy and fuel is transformed into mechanical energy to move the vehicle. Even turning on a light involves transforming electrical energy into light and heat. Recognizing these transformations helps us appreciate the role of energy in our daily routines. Simple machines like levers, pulleys, and inclined planes make work easier by changing the direction or magnitude of a force. However, no machine is perfectly efficient. Some energy is always lost, usually as heat due to friction. The efficiency of a machine is the ratio of useful work output to the total work input, expressed as a percentage. Understanding efficiency helps us design better tools and machines for everyday tasks. Friction is a force that opposes motion between two surfaces. While it can make tasks harder by requiring more work, friction is also essential for many activities like walking or driving. In terms of energy, friction converts some mechanical energy into heat, reducing the efficiency of machines. Managing friction is crucial in engineering, whether we want to increase it for safety or decrease it for efficiency. Energy sources are classified as renewable or non-renewable. Renewable sources like solar, wind, and hydro can be replenished naturally and are generally cleaner. Non-renewable sources such as coal, oil, and natural gas are finite and release more pollution. Understanding the difference is important for making sustainable choices and protecting the environment for future generations. Harness energy from various sources using different technologies. Solar panels capture sunlight and convert it into electricity. Wind turbines use the wind's kinetic energy to generate power. Hydroelectric dams use flowing water to spin turbines. Fossil fuels are burned to release chemical energy as heat and electricity. Each method has its own advantages and challenges, shaping how we power our world. Thermal energy is the energy of moving particles and matter. It's what we feel as heat. Thermal energy can be transferred in three ways: conduction, convection, and radiation. For example, when you touch a hot pan, heat is transferred by conduction. Boiling water circulates heat by convection, and the sun warms us by radiation. Understanding thermal energy helps us manage heating and cooling in our homes and industries. Energy efficiency means using less energy to perform the same task. Modern appliances are designed to be more efficient, saving both energy and money. For example, LED bulbs use less electricity than traditional bulbs for the same amount of light. Energy-efficient refrigerators and washing machines help reduce electricity bills and environmental impact. Choosing efficient appliances is a simple way to conserve energy at home. Chemical energy is stored in the bonds of molecules and released during chemical reactions. It powers everything from our bodies to batteries and engines. When you eat food, your body breaks down molecules to release energy. Batteries store chemical energy and convert it to electrical energy when needed. Fuels like gasoline release chemical energy to power vehicles. Understanding chemical energy helps us use resources more wisely. Nuclear energy comes from splitting atoms in a process called fission. This releases a huge amount of energy, which can be used to generate electricity in nuclear power plants. Nuclear energy is very efficient and produces no air pollution, but it does create radioactive waste that must be managed carefully. It's also used in medicine and scientific research. Understanding nuclear energy helps us weigh its benefits and risks. Electrical energy is the flow of electric charge, powering everything from lights to computers. It's generated in power plants using various sources like coal, natural gas, nuclear, wind, and solar. The electricity travels through wires to homes and businesses. Understanding how electrical energy is generated and distributed helps us appreciate the infrastructure that supports modern life. Different energy sources have different impacts on the environment. Fossil fuels release greenhouse gases, contributing to climate change and air pollution. Renewable sources like wind and solar are cleaner but require land and resources to build. Nuclear energy produces radioactive waste. Understanding these impacts helps us make informed decisions about which energy sources to use and how to reduce our environmental footprint. Transportation relies heavily on energy, mostly from fossil fuels like gasoline and diesel. However, electric vehicles are becoming more popular, using batteries charged with electrical energy. Public transportation systems also work to improve energy efficiency and reduce emissions. The future of transportation will likely include more renewable energy sources, making travel cleaner and more sustainable. Our homes use energy for heating, cooling, lighting, and powering appliances. Most of this energy comes from electricity or natural gas. Simple actions like turning off lights, using energy-efficient appliances, and insulating your home can save energy and reduce costs. Smart home technology is also making it easier to monitor and manage energy use, helping households become more sustainable. Industries use large amounts of energy for manufacturing, processing, and transportation. Improving energy efficiency in factories and switching to renewable sources can lower costs and reduce environmental impact. Many industries are investing in new technologies to recycle waste heat, use solar panels, and optimize production processes. These changes are essential for building a more sustainable future. Storing energy is crucial for balancing supply and demand, especially with renewable sources like solar and wind. Batteries, pumped hydro storage, and compressed air systems are common solutions. These technologies store excess energy when production is high and release it when demand increases. Advances in energy storage are making renewable energy more reliable and accessible. Smart grids use digital technology to monitor and manage the flow of electricity. They help balance supply and demand, integrate renewable sources, and improve reliability. Smart meters and sensors provide real-time data, allowing utilities and consumers to make better decisions about energy use. These innovations are transforming the way we produce, distribute, and consume energy. The way we produce and use energy has a major impact on the climate. Burning fossil fuels releases greenhouse gases which trap heat and contribute to global warming. Transitioning to renewable energy sources and improving efficiency are key strategies for reducing emissions and slowing climate change. Every action counts in building a more sustainable planet. The future of energy is bright, with new technologies making it possible to generate, store, and use energy more efficiently than ever before. Innovations like solar panels, wind turbines, and advanced batteries are leading the way. As we continue to invest in research and development, we can look forward to cleaner, more reliable, and more affordable energy for everyone. Saving energy doesn't have to be complicated. Simple steps like turning off unused lights, unplugging devices using public transport, and choosing energy-efficient appliances can make a big difference. These habits not only lower your bills but also help protect the environment. Every small action adds up to a larger impact, making our world more sustainable for future generations. We've covered a lot in our exploration of work and energy. From understanding what work means in physics to exploring different forms of energy and their real-life applications, you now have a solid foundation. Remember, energy is all around us, powering everything we do. By understanding how it works and making smart choices, we can use energy more efficiently and sustainably. Thanks for joining this journey into the science of work and energy.